Okay, we are going to write the equation of a line in the slope-intercept form that has these 2 points, 1, -6, and the other one is -1, 6. Remember, we have to first find the slope and then use the point-slope form. At the end, isolate the y so we can get the slope-intercept form. And now, let me show you how to do this. First, we have to know and remember the slope formula. We use m for the slope. And the formula says we have to have the y2 minus y1 divided by x2 minus x1. Okay? And now, it's a really good habit for us to come here and do the labeling. Since this is the first point that I have, I will label this as x1, y1. Okay? And this is the second point. I will label this as x2, y2. And then we are ready to plug in these values into the formula accordingly. Okay? Now we have this right here, y2, which is the 6, right? So I put down 6 right here for the y2. And then minus from the formula. What's y1? y1 right here is -6. So I put down a parentheses, another -6, like this. First of all, you see that this negative is from the formula, but this negative is because y1 is negative, okay? And then divided by, this is the fraction bar, x2 is this, -1, so put down -1. And since there's nothing in front, I don't need to use the parentheses, alright? And then we continue, bring down the minus from the formula, and then x1 is this one right here, okay? And now, let's work this out and do it carefully because we have a lot of negative signs, okay? So, as you can see on the top, this is 6 minus -6. But we know minus becomes what? Becomes positive, right? So, on the top, we pretty much have 6 plus 6. And you can just work that out, which is going to be 12, right? And then, on the bottom, we have -1 minus 1. That's going to give us -2, okay? At the end, 12 over -2, we get negative. Once again, because it's positive over negative, we have negative. And then 12 over 2 is 6, but altogether it's -6. And this right here is a slope, okay? This is the m that we're going to use. And I'm just going to write down the m like this. Next, we are going to set up, right? We're going to use the point-slope form to set up. And I'll just write it down for you guys, but you have to remember it. The formula is y minus y1, that's equal to m times x minus x1. This right here is the point slope form of the line. Always use this to set up. At the end, isolate the y and you end up with the slope-intercept form, okay? Well, you see, we have the x1, y1 from here already. So let's just use these values. And then right here, the m, which we found earlier, it was -6. And now let's just plug in the values. First of all, this y stays, right? And then the minus stays. But the y1 is -6. So I will put down parentheses -6 for the y1 like this. Continue, this is equal to m, which is this -6, okay? So the m is -6 right here because the m is right here. Parentheses, the x stays, minus the x1 is this one right here. So we have the -1, okay? So as you can see, the x and y in black, they stay, and then the x1, y1, and the m values, we have to plug in this right here. At the end, we just have to work this out. But first of all, let's do this. You see, on the left-hand side, we have a minus -6. So altogether, this is y plus 6, right? And on the right-hand side, we are going to take the -6 and distribute into the parentheses like that. -6 times x, that's -6x. And -6 times -1, that's plus 6, okay? And now, remember, the slope-intercept form is what? We have to have the y is equal to mx plus b. The y has to be by itself. This right here, the y is not by itself yet. We have y plus 6. So why don't we minus 6 right here, so they'll be cancelled, and we'll do the same thing right here on the right hand side. And I line out with the 6 because these are just the numbers. I didn't put down the negative 6 right here with the x term, okay? At the end, we have the y by itself, and this is equal to negative 6x, and 6 minus 6 is 0. You don't have to put down the plus 0. Doesn't matter. Just write it down like this. Answer, y is equal to negative 6x. All right? This is the slope-intercept form, and that's it.